This is Citadel Civil Engineering with Dr. Wood, and this is CIVL202 Statics. And in this lecture, we're going to go over the basic theory for Learning Objective 3.5.3.2, looking at the method of sections for truss analysis. So when thinking about truss analysis, we've talked about the method of joints, in which we go joint by joint through a structure. We've also talked about the identification of zero force members by inspection using two cases. And now what we're going to talk about is the method of sections as applied to trusses. Now we've actually talked about method of sections before when looking at the internal forces on beams, but now we're going to look at it in terms of internal forces on trusses. So when we were talking about beams and the method of sections, we said that we would cut the member open and expose the internal forces. And for beams, that included normal force, shear force, and moment. However, and then we could use our equations of equilibrium to solve for those three unknowns. However, for the method of sections for trusses, every force in a truss is going to be a normal force, either tension or compression, because trusses consist of two force members. But the basic idea is the same. The first thing we'll do is we'll solve for external reactions. So we would first, because before we can look at internal, we have to evaluate the external. So we'd do a free body diagram for the whole truss, and then we would write our equations of equilibrium and solve for our reactions. Once we got the reactions in place, we can begin to think about our internal forces. So at this point, we could optionally use our equations of equilibrium, our zero force member rules to go through and identify any zero force members that we wanted by inspection. Or to do our internal forces, we will evaluate one side of the truss, just like we did one side of the beam, one side of the truss, using rigid body equilibrium, equations of equilibrium. And we said in 2D, that means we're going to get 3 equations of equilibrium. That means that when we cut the truss in half into 2 pieces, we can only expose 3 unknown internal forces. So we're going to want to cut fewer than or equal to 3 unknown internal forces, 3 unknown members. So that's going to be our big takeaway right there, is that we're going to cut our 3 members. Once we've cut the 3 members, we will do our free body diagram of one side. It doesn't matter which side. We'll just pick the side that's most convenient. And then once we have our free body diagram, we'll write our equations of equilibrium and then solve for up to 3 unknown member forces. So we'll solve for our unknowns. There's one big warning here in this, is that we're only cutting members. We do not cut joints. If you cut joints open, all sorts of horrible things happen. So we're going to only cut members in the middle, expose the internal forces, assume that they're in tension, and then move on. Keep in mind that when we write our equations of equilibrium, that'll be 3 equations, and then less than or equal to 3 unknowns that we can solve for. Okay, so hopefully that seems clear. So that would lead us to the place where we might want to think through the 2 different truss analysis methods that we've learned about so far. And of course, we'll work an example problem together using method of sections, but it's very much like method of sections for for beams. It's just now we're exposing internal forces. Now, when we think about this in terms of our truss analysis comparison, we have the method of joints versus the method of sections. Two different ways that we can do our truss analysis. The method of joints is going to be using two equations of equilibrium per free body diagram because it's always concurrent force systems. Method of sections can use three equations of equilibrium per free body diagram per cut we make because we have rigid body equations of equilibrium going on there. We can think of this as analyzing joint forces directly. And those are equal to our internal forces. Of course, method of sections is basically just looking at internal forces, and then we just have to assume that the joint forces are the same, which is a safe assumption. And then the problem with the method of joints is that because you're working your way around the problem, we have the potential of carrying errors forward in our calculations such that we don't really know we've made a mistake until we're done. With method of sections, we can quickly ID forces for a particular member. Because you can cut straight to it. Whereas a method of joints, you might have to start on one side and work your way across going from joint to joint. Method of sections, you can go straight to and cut. So this would be very useful if we were doing some sort of calculations on a bridge inspection where we were looking at a truss and we identified a member that had a weakness or something we wanted to look into. We could solve for our external reactions, cut the truss in half going through that member of interest, and then we could immediately solve for that member of interest without having to work our whole way through the truss. And so that's kind of a comparison of the method of sections versus the method of joints. Method of sections, I think, is probably faster in most cases to get where you want to go. It also means that each cut is more or less its own problem because you're carrying forward less information from previous analysis. Method of joints, I think, is actually easier, but is more time consuming because you're having to look at every single joint as you go along. And if you make a mistake, you'll find out at the end, and then you'll have to go back and find it. So that gives you method of sections. Again, we'll cut it in half, cut up to 3 members, and then analyze one side or the other, exposing those 3 normal forces, and we've compared the 2 methods. So I look forward to seeing you in class. Thanks.